This is my video proof that the quotient of two continuous functions is also a continuous function. So let g and f be continuous at the point x0 with g of x0 specifically not equal to 0 so that we don't divide by 0. Well, by limit 3.3, there's going to exist a delta prime, which I'm going to use delta prime because it lets me get a nice delta at the end, be greater than 0, and an alpha greater than 0, so that for the absolute value of x minus x0 less than delta prime with x an element of d, we're going to have the absolute value of g of x greater than alpha. So let's go ahead and choose an epsilon greater than 0, but then we're going to go ahead and let epsilon prime equal alpha times the absolute value of g of x times epsilon. And now since all this is going to be greater than 0, we can find we're going to go ahead and say that there's going to exist a delta double prime greater than 0, so that if the absolute value of x minus x0 is less than delta double prime and x is an element of d, then the absolute value of g of x minus g of x0 is less than epsilon prime, because that's the definition of being continuous. And we're going to want to remember that we have that all less than epsilon prime because we're going to use it again in a minute. So let's go ahead and let delta be the minimum of delta prime and delta double prime. And then we're going to go ahead and say, so that delta is greater than 0, and the absolute value of x minus x0 is less than delta with x an element of d, we have the function 1 over g of x minus 1 over g of x0. Well, with a little bit of algebra, we can get it into the absolute value of g of x0 minus g of x all over g of x times g of x0. Well, that term on top is the exact term we had in that earlier inequality, so we can actually just say all that is less than epsilon prime over the absolute value of g of x times g of x0. Well, we're going to go ahead and say that we can make the denominator greater than or equal to alpha times g of x0, or alpha times the absolute value of g of x0, since, but if you make the denominator smaller, you end up making the term bigger. So, that whole thing is actually less than epsilon because, or that whole term right there is actually equal to our original epsilon. So hey, look what we get here. Absolute value of 1 over g of x minus 1 over g of x0 less than epsilon. So that shows that the function 1 over g is continuous at x0. Oh hey, but now that we know that f is continuous at x0 as well, we can reduce this to being the product of two continuous functions at x0, which, based on previous proofs, is a continuous function. QED.